Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section 4.7. This is number 14 in the homework, and it says determine the limit as x approaches 0 from the right of the function x raised to the 21 to the x power. And on page 306, we have a procedure for indeterminate forms in the form of 1 to the infinity, 0 to the 0, and infinity to the 0. So if we're plugging in 0 from the right, we can see that the x here is going to be approaching 0, and the exponent here is also going to be approaching 0. So this does follow under that indeterminate form, and it gives you a procedure for solving it. I kind of want to explain it a little bit different, just so we can kind of see the entire process. So if we're looking at x raised to the 21 to the x, they use a little trick here, and that is this. So we're just looking at the function right now. Now remember, e and natural log are inverse functions of each other, so they cancel out. So if I put e to the natural log of something, well, then that's really just the same as whatever I'm putting there. So I'm going to do x raised to the 21x. So since e and natural log cancel out, I just get x to the 21x, which means I really have essentially the same function here. Now the reason I do this is because I can use the rule, the logarithmic rule that says I can move the exponent out to the front of the function. So then this is equal to e. I'm going to take the 21x and move it out to the front of natural log of x. And remember, this is the limit as x approaches 0 from the right. Now, if we take a look all the way back to limits, page 106, theorem 2.12, we know that if we have a function that is both continuous and differentiable on the interval, which x raised to the x is, anything right of 0, that means that, and this is a composite function, that means we can actually take a look at the limit using this with the inner function here. So this whole thing is really going to be equal to e raised to the limit as x approaches 0 from the right of 21x natural log of x. So right now we're just really going to be computing this limit here using that theorem 2.12, and then we're going to plug that back in for the exponent for e when we're done. So let's take a look at this one right here. So that's going to be the limit as x approaches 0 from the right of 20, oops, I should have wrote 21x, excuse me, 21x times the natural log of x. Now I want to write this a little bit differently, just so I can get the, or use our L'Hopital's rule. So the limit as x approaches 0 from the right of, and I'm going to keep the natural log of x on the top, natural log of x. And on the bottom, I am going to put, I'm just going to put, oops, I think the 21 stays on top, doesn't it? Let me change that. So only the x is going down to the bottom. So this will be 21 natural log of x. And then on the bottom, I'm going to change the x to a -1, just bring it down to the bottom. Now, if I take a look at that and plug in the 0 going from the right, so the natural log, and we can kind of see this if we want to look at the calculator here. If we do natural log of a really small number, so we're approaching 0 from the right hand side, so maybe 0.0001, we'll see that we're getting extremely, or the numbers are going negative. So if I do like a natural point, a bunch more, closer to 1 here, this is approaching negative infinity. And on the bottom here, remember x is this, x to the -1 is the same as 1 over x. And that's going to be approaching positive infinity as we let our x values get smaller and smaller. So this thing is going to be equal to negative infinity over positive infinity. And that fits our L'Hopital's rule. So now we can take the derivative of both the top and the bottom. So This becomes the limit as x approaches 0 from the right. Remember, the derivative of natural log of x is just 1 over x times 21, which is going to be 21 over x. And on the bottom, that's going to be negative x to the negative 2 when we take the derivative of that. Let's rewrite that as 21 over x times the reciprocal of that, which is just going to be a negative x squared. And that's going to give us, I shouldn't use like an x like that for that, but that's all right. It's going to give us negative 21x. And now when we apply the 0 from the right, the limit of that's just going to be 0. So we're going to take that 0 and put it back into here, which means we get e raised to the 0 power, which is just equal to 1. And that is how we solve it. If you have any questions, please let me know, and I hope you all have a great rest of your day. Thanks.